tomorrow to share with us your particular view of how our past and our present may well affect our future. Carl, thank you very much.
Thanks very much, Senator Dernberger, Senator Gore, Senator Burdick. I'm glad to be here. As I understand my function, it is to give some sense of what the greenhouse effect is, to try to say something about greenhouse effect on other planets, to again underscore that this is a real phenomenon, and then perhaps I can take the liberty to say a few remarks about what to do about it. The power of human beings to affect and control and change the environment is growing as our technology grows. And at present time, we clearly have reached the stage where we are capable, both intentionally and inadvertently, to make significant changes in the global climate and in the global ecosystem. And we've probably been doing, on a smaller scale, things like that for a very long period of time. For example, slash and burn agriculture, which has been with us for tens of thousands of years probably, changes the climate to some extent by changing the albedo, the reflectivity of the Earth. That massive changes have occurred is clear from the historical record. For example, Egypt was once the breadbasket of the Roman Empire. It may be the same role as the American Midwest plays today. That is certainly no longer the case. It's not a greenhouse effect issue. It may be an overgrazing issue, but is an example of how humans are perfectly capable of making these unexpected and inadvertent changes. Because the effects occupy more than a human generation, there is a tendency to say that they are not our problem. Of course, then they are nobody's problem. Not on my tour of duty, not on my term of office. It's something for the next century. Let the next century worry about it. But the problem is that there are effects, and the greenhouse effect is one of them, which have long time constants. If you don't worry about it now, it's too late later on. And so in this issue, as in so many other issues, we are passing on extremely grave problems for our children when the time to solve the problems, if they can be solved at all, is now. If you ask what determines the Earth's climate, clearly the main thing that determines it is sunlight. Sunlight is what heats the Earth. Not all the light that arrives at the Earth from the sun goes to heating the Earth. Some of it is reflected back. It's just the part that is absorbed. And what happens is there's a certain rate at which sunlight is absorbed by the Earth's surface, and there's a certain rate at which the Earth's surface radiates to space. What comes from the sun is in the ordinary visible part of the spectrum that our eyes are sensitive to. What the Earth radiates into space is in the infrared part of the spectrum, longer waves than red, that our eyes are not sensitive to, but it's as legitimate excuse me, a form of light as the kind that we're used to. Now, if you calculate what the temperature of the Earth ought to be from how much sunlight is being absorbed, equaling how much infrared radiation would be radiated to space, you find that the Earth's temperature, by this simple calculation, is too low. It's about 30 centigrade degrees too low. And why is it too low? It's too low because something was left out of the calculation. What was left out of the calculation? The greenhouse effect. The air between us is transparent, except in Los Angeles and places of that sort, in the ordinary visible part of the spectrum. We can see each other. But if our eyes were sensitive at, say, 15 microns in the infrared, we could not see each other. The air would be black between us, and that's because, in this case, carbon dioxide. Carbon dioxide is very strongly absorbing at 15 microns and other wavelengths in the infrared. Likewise, there are parts of the infrared spectrum where water vapor absorbs, where we could not see each other if we were only as far apart as we are in this room. If you add these infrared absorbing gases to a planet, then what happens is the sunlight comes in as before, but when the surface tries to radiate to space in the infrared, it is blocked, it is impeded by the absorbing gases. And so the surface temperature has to rise so that there is an equilibrium between what comes in and what goes out. So this is the greenhouse effect. It is a misnomer for more reasons than one. It's a misnomer in particular because that's not how the florist greenhouse works, but that's a very minor point. There are other gases which absorb in the infrared, many of which have been mentioned already: nitrous oxide, methane, the halocarbons, and these are products partly of agriculture. It's fertilizers, refrigeration, aerosol spray cans, and so on, all products of our technology. We don't generate much water into the atmosphere, but we certainly do generate a great deal of carbon dioxide through the burning of wood and fossil fuels, an apparently benign activity. Who could object to humans burning oil and coal, gas, and wood? I'd like to stress that the greenhouse effect makes life on Earth possible. If there were not a greenhouse effect, the temperature would, as I say, be 30 centigrade degrees or so colder, and that's well below the freezing point of water everywhere on the planet. The oceans would be solid after a while. A little greenhouse effect is a good thing. But there is a delicate balance of these invisible gases, and too much or too little greenhouse effect can mean too high or too low a temperature. And here we are pouring enormous quantities of CO2 and these other gases into the atmosphere every year with hardly any concern about its long-term and global consequences. Now, certainly not all aspects of how increased CO2 and other gases into the atmosphere affect the climate are known. There are still many uncertainties, although the overall picture is, I think, quite clear and quite widely understood and accepted. But there are questions about aerosols, about clouds. You heat up the Earth. How much increase or decrease in cloudiness is there? How does that change the albedo or reflectivity of the Earth? There's questions about the ocean and its response time to an increase in CO2. There are feedback effects. And therefore, it is certainly worthwhile to spend some additional money on further research on the subject. Another point is that the significant temperature changes on the Earth between ice ages and out of ice ages, glacial and interglacial time periods, seems to be connected with quite small changes in the amount of sunlight that reaches the Earth due to changes in the Earth's orbital properties, and that is a suggestion that the Earth's climate system may be very delicately dependent on the sorts of factors that we're talking about here, and that's why it makes sense to study past climatic change on the Earth as an attempt to obtain some calibration. Another source of calibration is the other planets. Every planet with an atmosphere has some degree of a greenhouse effect. The most spectacular case by far is the greenhouse effect of Venus. It's the nearest planet. It's a planet about the same mass, radius, density as the Earth, but it is spectacularly different in several respects, one of which is that the surface temperature is about 470 degrees centigrade, 900 Fahrenheit, and that enormous temperature is not due to its being closer to the sun, because Venus is surrounded with bright clouds, and in fact, because it reflects so much light back to space, if that's all that was happening, it would be cooler, not warmer, than the Earth. The reason for this absurdly high temperature on the surface of Venus, which is well understood. I mean, Soviet spacecraft have landed on Venus and, in effect, stuck out a thermometer. There's no doubt that the surface temperature is very high, and later U.S. spacecraft have as well. The reason is a massive greenhouse effect in which carbon dioxide plays the major role. Now, the amount of CO2 in the Venus atmosphere is much larger than here. The atmosphere is almost entirely carbon dioxide, and there's 90 times more of it there than here. But it is an indication of what can happen in an extreme case. You look at Mars or Jupiter or Titan, the big moon of Saturn, and you have additional examples of greenhouse effects. Different gases, different amounts of sunlight reaching the surface, different planetary albedos and cloudiness, and in all those cases there is also a greenhouse effect. In addition, it has been possible to calculate those greenhouse effects fairly accurately, so that the kind of theoretical armamentarium which is used to calculate the greenhouse effect changes on the Earth, is also used for other planets and therefore can be calibrated to some extent against those other planets. If we keep coming out with the right answer in all those different cases, then probably we understand fairly well how greenhouse effects work. It would, however, be worthwhile, along the lines that Senator Gore was talking about, to have an increased program through NASA to understand the greenhouse effects on other planets. This might be a very practical application of planetary exploration. As you've heard, the best estimates, they certainly have some uncertainty attached to them, are that at the present rate of burning of fossil fuels, the present rate of increase of minor infrared absorbing gases in the Earth's atmosphere, that there will be a several centigrade degree temperature increase on the Earth, global average, by the middle to the end of the next century, and that has a variety of consequences, including redistribution of local climates, and through the melting of glaciers, an increase in global sea level. There is concern on a somewhat longer time scale about the collapse of the West Antarctic ice sheet and a general rise of many, many meters in sea level. So we have a kind of handwriting on the wall. Certainly there's more research to be done, but as I say, there is a consensus. What can be done about it? The idea that we should immediately stop burning fossil fuel has such severe economic consequences that no one, of course, will take it seriously. But there are many other things that can be done. One has to do with subsidies for fossil fuels. More efficient use could be encouraged by fewer government subsidies. Secondly, there are alternative energy sources, some of which are useful, at least locally. Solar power is certainly one that might be of more general use. Safe fission power plants, which are in principle possible. And then on a longer time scale, the prospect of fusion power. Fission and fusion power plants, in principle, vent no infrared active gases, and therefore, whatever other problems they may provide, they do not provide a greenhouse problem. I'd like to close by just saying a few words on the kind of perspective that this problem, as related problems, pose to us. Here is a problem which transcends our particular generation. It is an intergenerational problem. If we don't do the right thing now, there are very serious problems that our children and grandchildren will have to face. It is also a global problem. It is no good if just one or two major industrial nations take major steps to prevent a major increase still further in CO2 and other greenhouse gases, because other nations may, through their industrial development, cause the problem by themselves. And not to say that this is inevitable, but just to give an example. The largest coal reserves on the planet are the United States, the Soviet Union, and China. China is undergoing a very major industrial development. And the burning of coal is certainly something that must be very attractive for the Chinese looking into the future. I would say that there is no way to solve this problem, even if the United States and the Soviet Union were to come to a perfectly good accord on this issue without involving China and many other nations that will be developing rapidly in the time period we're talking about. So here is a sense in which the nations, to deal with this problem, have to make a change from their traditional concern about themselves and not about the planet and the species, a change from the traditional short-term objectives to longer-term objectives. And we have to bear in mind that in problems like this, the initial stages of global temperature increase, one region of the planet might benefit while another region of the planet suffers. And there has to be a kind of trading off of benefits and suffering. And that requires a degree of international amity which certainly doesn't exist today. I think that what is essential for this problem is a global consciousness, a view that transcends our exclusive identifications with the generational and political groupings into which by accident we have been born. The solution to these problems requires a perspective that embraces the planet and the future, because we are all in this greenhouse together. Thank you, Mr. Chairman.
Well, thank you very much. Just a frustration on international amity. Some of us made a brief trip in August through Sweden, Switzerland, Germany, and then I went into Poland, and concerned about what we call acid rain and some of those consequences. And as I went, the urge in me for some forum for international amity, it kept crying out, particularly when I got to Poland, which is the home place of my mother's side of my family, and to see the self-destructiveness of that economy and on the people of that country, and the lack of amity on the part of the Czechs and on the part of the East Germans. And it's just a frustrating experience. All of you must experience it every day of your lives. And I hope there is an answer in something other than legislation. But it is your concerns and those of many of us, people who are familiar with some parts of this problem and related problems, I guess have to somehow take this place beyond an amendment to require the United States contribution to the United Nations to be no greater than the contribution of the Soviet Union, and to somehow lift the people that claim a right to a place in the United States Senate beyond that kind of a view of the world, and lift it up somewhere closer to the real issues that affect people. And I had to say that. I was listening to your comments. Let me ask you, and I intend to ask the other witnesses this, and that is whether the following is an accurate summary of the current state of our knowledge on this subject. Now, for the first time, there is international scientific consensus that global warming can and will occur. While there's still uncertainty surrounding these predictions, it runs in both directions. That is, while global warming could be less than expected, it is at least as likely that it will be much worse. Third, all predictions are based on the assumption that a new man-made atmosphere will behave in the same way that natural atmospheres have in the past. Fourth, global warming, much like fever in a human being, is serious in itself, but is also a symptom of massive perturbation of the natural, physical, and chemical processes. And fifth, relatively painless actions can be taken which would slow the warming trend. For example, the use of CFCs and spray cans could be banned throughout the world. Maybe. Cars and trucks could be required to meet stringent carbon monoxide standards, such as those in the United States. Again, maybe, depending on our international amity. And forests can be reseeded. Is that a fairly accurate summary of the current state of our knowledge?
The only statement in there that I would have some quibble with is the one which goes that scientists are assuming that the atmosphere with the increased infrared absorbing gases in it will act the same as the present atmosphere. I don't believe there's any such assumption. There are calculations from first principles, but apart from that, what you read seems.
Yeah. You were invited to testify because you're something of a scientific generalist, and one of your best qualities is the ability to explain complex scientific issues in a way the layman can understand, and you have also worked on a variety of these issues. One scientist who works in this field was recently asked why he was devoting so much time and attention to it when there seemed to be more urgent problems, and his response was that in his judgment, climate alteration was the most serious threat to humanity and global peace short of nuclear war. Those seem like strong words even from a person who's committed his entire life to the problem. You are more of a generalist than the person I'm quoting, and you have spent time considering the implications of other threats, including nuclear winter, in the context of potentially cataclysmic events. How would you score climate alteration?
I recognize the need for a rank order of catastrophes, so we know which one to devote our attention to first. But I would hope that we could concentrate on several potential catastrophes at the same time.
Which two or three?
I certainly agree with your anonymous informant that nuclear war is far and away, heads and shoulders, the most dangerous threat to the nation and the world and possibly the human species. I also agree that the sorts of climatic effects that we're talking about today are very serious because they have global purview and because they are so intimately tied to something which we are so reluctant to give up for clear economic and other reasons, namely the burning of fossil fuels. In 1945, after the first nuclear explosions, Einstein said that everything had changed except our way of thinking, a remark that certainly is still applicable today, and I think is applicable to this particular issue. And that's what I was trying to stress in my testimony, that there is a kind of global and intergenerational thinking that is essential for dealing with these problems, the nuclear war issue as well, and other candidate catastrophes like AIDS and other new epidemic diseases, all of which cannot be resolved except on an international global basis. The eradication of smallpox, for example, to take a successful example, was done at the expenditure of a few tens of millions of dollars by a planetary effort by the medical community, and is an example of a problem that certainly was considered very difficult some 1,000 years ago, that is now it's completely gone. There are no more cases of smallpox on the planet. So it's a reminder to us that these problems can be solved, but not if we persist in keeping to our narrow frames of interest in space and in time.
Thank you. Mac?
Yeah. Dr. Sagan, a lot has been written about, a lot of people have spoken about some of the adverse effects of increased carbon dioxide and other gases. Are there any benefits? That is, one can argue that in some of the colder climates of our country, warmer temperatures would help.
Well, having just come from upstate New York, I know what you mean, Senator Baucus. The distinguished scientists who will follow me on this panel would be better qualified than I to answer that question, but it is clear that increased carbon dioxide for many plant species produces a more luxuriant growth That's true both of crops and of weeds, but that might be considered a benefit. Also, the one that you just talked about, there are places that are cold which will be happy to be warmer. There are places that have a moderate climate that will be unhappy about being warmer, and that's that balancing out of pluses and minuses I was talking about before. But I don't think anybody will be happy about the inundation of all the coastal cities on the planet, except, I suppose, the people who live on the new coastlines, who will be delighted to have boat traffic.
Yeah. Is there any difference of opinion at all within the scientific community over this trend? That is, with increased carbon dioxide and other gases building up, that by sometime next century, say year 2075, year 2080, that the overall temperature will have increased X number of degrees Fahrenheit.
Defer to Drs. Manabe and others on this, but if you look at the 1982 National Academy report, I forgot the exact title, but climatic effects of CO2, a reassessment, something like that, they talk about a few dissenting scientific papers, and that is a few scientists who say the effect is not nearly as severe as has been widely advertised. And the Academy's report gives a very succinct explanation about why these studies are inadequate.
So in your judgment, the vast preponderance of the thinking of the community is in accordance with what you're saying?
Yes.
Okay. What's the best international arena within which to address some of these problems? I mean, we have to create a new forum, organization? Should we work within some existing organizations? Do we deal with this on an ad hoc basis? What guidance can you give us, at least in your thinking, as to how to get other countries to A, think about this, including this country, B, how to work on some cooperative, constructive basis?
Well, it seems to me that that the situation has to be arranged that everyone benefits. And a developing country that is being asked to forego readily available supplies of fossil fuels has to be given something of value in exchange. And if we develop fusion power plants that are effective, for example, then it seems to me there has to be a...
But I wonder if you've given any thought as to process. I mean, in addition to the information and substance on the process.
I think...
Carl, before you go into that, I'm going to have to break and get over to vote, and so I want to express my appreciation to you for being here today on behalf of all of us and those who aren't here. Okay.
I've got to leave too. I mean.
Okay, well, I didn't have a good answer anyway. So.
Well, you have about 15 minutes to think about it.
We'll recess the hearing. Thank you very much for coming. Did you want Carl to stay to ask more questions?
Oh, well, I have more questions, so we can, if he's busy, I can put him in the record. I'll write questions to you. Okay, thank you.